everyone, welcome again. We are going on with our lesson or tutorial, still on the first part of the tutorial, and today we are going to finalize the last part of the first part. It is creating slab strips, and also we'll do an introduction to load combination and analysis. Okay, now back to our software. This is where we ended. We had created normal beams and normal slabs, and as I formerly told you, in order to create slabs, you have to do some load combinations. So here we go under loading and unloading. We'll come here to load cases and combination. When you select this, you will get different kinds of load combinations for the dead load, live loads, and you can also get combination for the dead loads, live loads, and as well as uh, earth pressures and wind loads and others. Now, if you click here, you're going to get you'll be shown on the different types of load cases. And here, this is the loading generator. You can select any kind of loading that which you like. Remember, according to BS, for the dead load, the coefficient is 1.4. Live loads. And for the live loads, the coefficient is 1.6. Now, this is the loading pattern for your beam. That is, you have a positive moment and a negative moment, positive, negative moment, and negative moment. So we have selected this and this. This is automatically chosen by the code, because remember, this is like a continuous beam whereby the first loading, the top part will have a positive moment, or the second pattern will be the adjacent span will be having a positive moment for here, while here it will be having a negative moment. So this is just a loading pattern for continuous beams or spanning members in the frame of a structure, so that to make sure the loads are effectively analyzed or effectively designed for the structure. So these are the vertical loads combinations, and also you've got the horizontal load combination. Where here you've got national loading, that is either in X or Y direction. And also there's also seismic loading, as I was telling. This is earthquake loading. So for this to function, you have to have a code that utilizes seismic loading, but for BS doesn't check for earth loading. So when that is done, say I can delete all of this here and delete all the combinations here. When this is done, I go to loading generator, and I will not pick this load for the horizontal, just vertical, just pick these two. And I say okay. When I come here, I'll just delete this, delete that. I just left with normal 1.4 and 1.6. That is how we normally design the structures theoretically. So I just press OK and I say OK. Okay, once you press OK, we get back to our working area. And now, under modeling, I'll go to create a slab strip. Now remember, these slab strips will automatically generate, or I would rather say, do the analysis and design for the slab here. Uh, Now just to check something, under settings, it's a moment under setting and under slab. And check the rebars. Select it. See, now the rebar pattern, let's set to straight. Now minimum still bar. Okay, okay, finish. Okay. Now we come back to modeling. We'll go to slab strip. Now remember, depending on the distribution of your slab, as I told you, for example, for this one, it is showing you that the reference point of the load is in one direction. This one also is also in one direction, but this is a two-way span slab. Okay. Two-way span slab, two-way span slab, two-way span slab, one-way span, one-way span, one-way span. Now, so if you have a two-way span slab, it means that you have a strip in the x direction as well as in the y direction. Now to do this, we are starting with x direction, and we have different types of strip. You have analytical strip, finite element strip, and manual strip. For the finite element strip, this is only used when you have a ribbed slab or wafer slabs. I will show you this in the later part of the course. And for the manual strip, this is the one in which you'll be doing it manually, but we usually go with the analytical strip. Now for the analytical strip, you have to select the boundary conditions. What are the boundary conditions? Now the boundary condition here, it means that how is your slab located right here. This here is it shows a cantilever slab. That is there's a slab here, this is a beam, and then there's a slab is continuing. So if your start point is on a cantilever, for instance, if you had a cantilever slab around here, then we had to select this one here, and this one, it shows the starting point is a beam, so you can select a beam. And for this one here, it is showing you that the starting part is a slab. The same way for the endpoint. If the endpoint is a cantilever, you have to select this. If it's a beam, you have to select this. If it is a slab, you have to select this. So coming back to here, we want to put along the x-axis this direction, going to the right. Look here, the starting point is a beam, the end part is a beam. So I have to choose this and this. So I just come here, left click, hold control to make your rebar straight, and left click again. Now let me tell you something. Remember that this slab was a one-way spanning. It is spanning the y direction. It means all the rebar have to go along the y direction. Okay, we come again here, left click, hold down control. Remember, I'm doing that because the end of all this part here is a beam. That's why I'm leaving these conditions as they are. So again here, You cannot put it on an empty area, so you have to end first there, again here, then again here. Now look here, this scale first. This is a one-way spanning slab, but it is along the direction of y. So what you have to do, we are going to start here and end it on this beam. We select here, hold down control to make it straight, and hold down control to the beam point. Okay, you see it will curtail on this beam. And then from this part here, I will select, this is we're coming from a slab going going to a beam, because this end has a beam. So I will remember now this is in the y direction, so the x direction is done. So I come here and change direction to y. Now I told you all this as one-way spanning. This is one-way spanning, one-way spanning, one-way spanning, and one-way spanning. So because I've already done this along the y direction, it means that these rebars are going to arrange themselves in this going along the y direction. So I'll just save in for this part here, for the y direction, I just have to click from here up to here. So my boundary conditions again. Also remember here to change, you have to go back to y1, and I'll change my boundary conditions to beam to beam. Then I start here, hold down control, down control, hold down control up to here. Okay, now get them that direction. Okay, hold down control, down control, hold down control up to here, in here, hold down control up to here. Okay, now you have it. You can see this, it was telling you the loads are spanning on this direction. That's why you put it on y, because these rebars will go with this line here. This ray shows you how the rebars are going to be arranged in this direction as well as in this direction. Okay, now I want to show you something. After doing this, now you're done with the slab strip. So uh, I just hit close. Then now let's look here, look here, look here. You see it is saying T12 at 250 centers, but it does not give you the numbers of rebars. Now to get the numbers of rebars here, you have to go under settings, go to slab, and under slabs go to rebars and say okay, put me down design. Okay, when you go to settings, go to slabs, under branches of slab, go to appearance. Under appearance here, select this, tick this box here, show number of bars in bar label. Okay, and also you can print steel bar total length. Now this is also important. Okay, after that select OK. Now I just say update. See now it is showing the number of bars 19T12, 19T, 19T, 70, 12 to 50 single center. Okay, easy. Your slab design and analysis is done. The only important thing to note here is how to put your slab strips. Remember how you are going to put them. Remember your boundary conditions. If it is a beam, you have to choose the center part of that dialog which was here. If it is the cantilever, here you have to choose a cantilever and so forth. So that was all on about load combination as well as slab strips. Can remember later on I'll show you on how to use the finite element strip, because we need to have an example that includes a rib slab or waffle slabs. Thank you again for joining. See you next time.